My name is Jan Christopher Vogt. I work for EPFL, the university in Switzerland where Scala started, now together with Typesafe. And I work on a project called Slick, which is also a Typesafe project. And I'm here to tell you about what Slick is and why you should use it when you talk to databases from a Scala program. Slick is a library written in Scala for talking to databases from your Scala programs. You write some queries like there on the left. You send it to the database, get back the results. The usual thing. You can also do inserts, updates, deletes, change the schema. And why do we need Slick? Well, we all know object relational mappers, and object relational mapping is a swamp. You can say Slick is to Hibernate and JDBC what Scala is to Java and Groovy. Slick is concise, it's scalable, it's safe, it's compositional, and I'm going to tell you in a bit in detail what I mean by that. Hibernate, on the other hand, is complex. You can build scalable applications with Hibernate, but you have to do it with caution, and it's also easy to build an application that does not scale very well. When you use Hibernate, you have to choose between either HQL as a query language to write your database queries, or Hibernate criteria queries, which is an API. And HQL is embedded as a string into your host language, Java or Scala. And in that sense, it's unsafe and non-compositional. We'll see an example in a bit. Criteria queries are an API, so it's safer to code against, and it's compositional, but it's also pretty verbose if you've seen it. And if you use JDBC or a norm, which is the layer on top of JDBC in the Play framework, you write SQL directly, and you also embed it as strings in your program. And that's also unsafe. And, well, when you try to compose strings, it gets pretty ugly. Back to our object relational mapping. Why is Slick easier? Because it chooses a better match. It maps to functional structures, to functional programming. SQL corresponds to the concept of for-comprehension in Scala. Rows can correspond to tuples and case classes. The expressions within these SQL queries can be described by lambdas. The concept of null can be mapped to the Scala concept of option, and there are more resemblances. And here is how I'll present Slick to you. First, I'll talk about the key features in comparison to the other solutions out there. Then, in the middle of my talk, I'll make a little live demo so you get a feeling how it is to code queries in Slick against the database. After that, I'll go through a couple of features for writing queries. And then we'll have a little look how Slick is actually implemented, how it works under the hood. And finally, I'll talk a little bit about what we're working on right now and what we're heading for in the future. So, first of all, if you know Scala, Slick is easy because you access database tables just like you access collections in Scala. You already know how to do it when you know Scala, so you know how to access databases. And in comparison to JDBC, Slick simplifies the session handling. In JDBC, there are two different types how you can handle sessions, and it works a little differently. And well, in Slick it's unified. I'll show that. I'll show examples for all of these in a little bit. Also, Slick is concise. Scala is a very concise language from the syntax, and Slick uses Scala syntax, so it's just as concise. Also, fetching results, the results from queries is a lot less painful than when you use JDBC. And Slick scales naturally because it's stateless. And it also scales because you have explicit control over what is transferred and when it is transferred. Slick is safe. It completely protects you from SQL injections. It also protects you from, errors in your queries, like if you use names that don't exist, if the types don't work out, if you have typos in there. You even get code completion in the editor because, it's an API and the compiler knows about what's there when you have the library on the class path. And Slick is composable. It's Scala code. You can abstract and reuse parts of queries just like you do with Scala programs. So easy. That's how a for-comprehension looks like in Scala, and that's also how a slick query looks like. And alternatively, you can also use the method syntax, which is identical to this for-comprehension syntax in Scala. The upper maps to the lower. Also for collections, same way for slick. That's how session management works in Slick. You do an import, and then you have this database object, which has several factory methods for creating a session. Either you can provide a connection string, or you can provide a data source object, for example, one that you got from a connection pool, or you can provide an NDI name. And apart from that, it works always the same. You can use this session to create a transaction. There's also a different method, which is automatically a scope that also closes your session automatically. Slick is concise in one regard regarding queries. This is an example of a Hibernate criteria query. And well, you're looking at it for a couple of seconds now, and you think you're still trying to figure out what it does. When you look at the exact same query in Slick, you just see it right away. And we all know that when code is more concise, it's not only more fun to read and also more fun to write and easier to read, it also probably contains less bugs. This is, well, Slick is also concise with regard to fetching results. So the above is, well, a SQL query where you prepare a statement with JDBC, bind a value, execute, create a list buffer to capture the results, and then iterate over the result set and put everything in the list buffer. Then close the result set, close the statement. In Slick, you just say .list, and you get a list with the results. Slick can do that because you state the information about the schema in a central place, and then Slick knows everything about the types. And it can just do that in one command. There are also different commands, for example, to not get everything at once, but iterate over the result set one by one if you have a large result set. Or get a different type, like a set as a, yeah?
And because you compare those two, where do you close the result set? Like in the second line, it's not obvious, but when is the
In this case, Slick does it automatically for you. The .list just gets everything, then closes the result set, and gives you a list of it.
And how do you deal with the pool of connections? So if you have pool of connections, then
if you have a connection pool, that you either get from your application server or that you use a distinct one, you need one that gives you a data source object. And then you can use the data source object here to get a Slick session from it. And when you close the session, then the connections return to the pool. And as I said, you can also, like this with transaction, there's also something with session, which automatically closes the session when you leave the scope. I said Slick scales naturally. And on the one hand, that is because it doesn't have caches. Well, you can easily put it on several nodes or several processors, and those don't interfere with each other. And it scales also in the sense that you explicitly state what is transferred. Well, in here, what you state in the yield part, the ID and the name, and when it's transferred, exactly when you call this method, .list or .forEach or the other ones that exist. Yeah, I guess some of you know this one. It's one of my favorite XKCD. And well, it shows a problem that still exists. If you embed a different language as a string into a host language, and then you combine it with some user input, it can easily happen that you suddenly have user input being executed as code. And well, SQL is an example where you embed a language as a string, and HQL as well. You can use prepared statements to get around that, but you have to do it. And the fact that Slick uses an API and is fully type checked gives you even more advantages. The Hibernate criteria query you see here is also an API, but there you state the field name as a string. So it doesn't check at compile time if it exists, or if you made a typo in there or something like that. You get that with Slick. And you get code completion in the editor as well. Slick also supports type-safe use of stored procedures. So you can, well, here the simple function call tells Slick there is a function day of week in my database. And actually in the H2 database management system, there is such a function, which takes a date and returns an integer which resembles the day of the week. And this way we tell, okay, there is a day of week function and it returns an integer. And then we use this in the second line where we define a function with a, well, a stated signature to make it type safe. And then we can use it within a Slick query. And if, well, we get all the benefits of type safety and having it known. I also said that Slick queries are composable. So let's assume this hypothetical schema where we have persons, and persons can have several interests, and persons can also own several cars. And now we have a software, and in different places of our software, well, in one place we're interested in the interests of people between 20 and 25. In a different place we're interested in what cars people between 55 and 65 own. You already see the commonality between the two. And the compositionality of Slick allows us to factor that commonality out. We can write a function person by age, which, well, filters the persons table, but it doesn't execute any query yet. It just creates an object that encapsulates this logic. And then we can use this as a component in a larger query, which we do below. And each of these will just generate one query, not a second one for the abstraction. One more thing you can do with Slick is if you use a database backend which has a feature which for some reason is not or not yet supported by Slick, you can always fall back to SQL. So, and well, it's not type safe in this case, but you still get the benefits from the unified session handling and from fetching results more easily, and there's still a benefit over JDBC. So that's like a little summary, and I also added another library, SQL, which, well, the people who use Scala, a few may know. It's another library which tries to do something very similar to Slick. It also provides a type-safe API for queries. We choose with Slick to write queries in the way Scala for-comprehensions are written in Scala. Well, the Scala collections work. SQL uses a SQL-like API. For some people prefer that because they are more familiar with SQL. We bet more on people who are familiar with Scala and like to write the queries the same way they write queries against collections. Also, there are some some implementation differences between SQL and Slick, where I believe SQL scales less well in the sense of extensibility of the language, not performance or something, but what you can do with the language. I can go into detail if somebody is interested at the end of the talk. Ask me about it. That's the supported database management systems of the solutions I talked about. You can look it up later in the PDF. Important things to mention is for Slick, we have an Oracle and a DB2 driver, but we didn't publish them yet. We're still sorting out licensing issues. And we are planning to support NoSQL databases with Slick, and we're in the middle of preparing Slick for that, but it will not happen until summer of 2013. We will start, well, we open up, the question was which databases. And we will open up Slick in general to support custom backends, so you can plug in your own database if you know how to do it. And we will offer a MongoDB driver for starters. MySQL is supported now. No, I said MongoDB will and no SQL databases, no SQL databases. I'm not sure if we are doing this ourselves, but it will be open so other people can do it. If there's commercial interest, you can always ask Typesafe to do it as a commercial thing. That's actually one angle to it as well. For when there's special commercial interest, Typesafe will provide this support. So Slick in the Scala ecosystem. Slick will be part of the Typesafe stack, and it will be the default database connector in Play in the next version. Play is the web framework. Some people, if you know, may know. Slick is the successor of the ScalaQuery library, which has been developed for a couple of years, which is also the Scala library. And Slick is also inspired by Link in the sense that we are opening it up for different backends, and there are similar ideas in there. So yeah, right now it's based on JDBC, but we're opening it up. And well, when we started Slick 1 year ago, I was working on a research project at the university called Scala Integrated Query, which explored a certain aspect of embedding type-safe query languages in Scala. And so ideas of Scala Integrated Query will eventually end up in Slick as well. But we're not there yet. If you want to use Slick, if you're on Scala 2.9, which you probably are because 2.10 is not finally released yet, you should still use ScalaQuery before it rebranded to Slick. And you can get this at scalaquery.org. Don't get discouraged by the version number. It's stable for production use. If you're playing around with Scala 2.10 or use it after the release, you can use Slick. Right now we have a 0.11 pre-release, and we'll release it as 1.0 in the, during Scala 2.10's RC cycle. So now for some live code. And just a reminder, we're still in the middle, so there are some slides coming after I'm done with this. But I want to give you a feeling now so you have feel a little how it is. We'll be building a little database application where there are persons and tasks for belonging to the people. So every person can have several tasks. And I'll show you how to set up Slick, how to describe the metadata, the tables to Slick, how to insert some data, how to write a particular query, and we will search for all people above a certain age, and then get the tasks for them and display them. And I'll show you how to do some abstractions as well in there. And the code is already online, the resulting code, and I'll actually work with that. So I just cloned the project, which already has an SBT project in there. SBT is the simple build tool for Scala. And I also set it up to have a plugin for Eclipse installed. So you can actually just use change into Slick presentation, and then you can do SBT Eclipse, and it will generate an SBT project, Eclipse project in there. So you can just import it into Eclipse. Usually this will take a little longer for you because it will download all the things, which I now have already cached. And now I open up Eclipse.
That was very fast, I have to admit. Didn't even have to import.
Well, yeah, that was from my trials. I already had it imported, but I import it again now. So that's the path. And well, it's already set up to download the Slick library and the dependencies from Maven. And that's the resulting code. So I changed to the branch where I have the template for the presentation. And when you have the libraries on your class path, the only thing you need to do is import the driver for the database you want to use. Here we import the H2 driver for the H2 database. And that's nice for the presentation because you can have it in memory. We just have an SQL database in memory now. And then we have this object Slick presentation, which is just the app we're running. And we'll first define some classes that for the person and for the task to hold the data record. Then we will define tables. Table objects are the way to tell Slick about the database schema. Then we will use Slick to actually, from the description, generate the tables in the in-memory database. Then we will insert some data. Then we will write the queries that, well, do what we wanted to do. And finally, we print out the results. So let's get started. So I'll write a person that will have an int SID, and it gets a name, and it gets an age, which is also an int for now. And so now I define the table object, which is the description for Slick about the structure. And it's a table of person objects. And it has an ID field. Which maps to a field ID in the database. It has a name field, which maps to a column name. And it has an age.
So the model has the case class person, and person has no dependency on table. It's the other way around.
Exactly. You'll see that in a bit. One more thing you need to define for Slick is the star projection, like the way you tell Slick what columns are actually in the table. And what we can do here now with this syntax is tell Slick how to, from the data it gets from a single row, how to create an object and how to extract data from an object. So it's not strongly coupled to the classes we define above. We just say person, well, this up there is a case class, and the Scala case class comes with an automatic factory method with the same name. Actually, it's the apply method of the companion object. And it also comes with an extractor where you can get the data out. So by passing these two to Slick, we will tell Slick, so this is the way you can create and deconstruct objects. And I forgot to state the name of the database table. Okay, so that's the description of the schema for Slick. And now we can first go ahead and create it. Oh, what I didn't mention before, what I already had in here is the session, the creation of a database session, which I showed before on the slide. And I use these transactions from the session to do my things. First create the table and insert some data in one transaction, and later in another transaction do my two particular queries I want to do. So I'll get a consistent picture.
What's DD1?
Sorry?
What's DD1?
DDL.
This is DDL. This gets to the data definition language, the SQL data definition language from the person's table description we gave to Slick. And create executes in the database. And this call gets the session from the implicit context.
And it has a side effect on persons.
Well, on
persons
in the way that it resembles the database table.
Yeah, before this call, it was different. After the call, persons is changed state.
Well, not person in the memory of Java, but persons in the database.
Oh. Okay.
And
Looks obscure that, like, on each transaction you create a data definition language.
this is just for the example. Like right now in the example, I at once create my tables, insert data, and then do the queries. In the real project, you would of course do that once and insert data where you need it. And yeah.
So can you do that like how do you do that in a program that first time it's executing, it can execute the DDL query, but it knows that the data already exists in the table. So basically, I want to write one code, and like I want to deploy in different servers, and you not be worried about what exactly. So the state of the database is right.
Yes.
I don't want to be like really worried about what happened on this database, what happened here. I want to write one code. I want to, expect to want the same for the database on everything.
Well, you can check if a table already exists.
The actual columns. So I have one table in test, and I have one in production. I have extra columns in test.
Well, yeah, we want you think about the evolutions of a database. When you add new columns during the evolution of your software, we don't have a framework for handling evolutions at the moment in Slick. Some frameworks, for example, web frameworks may provide that for you, and you can use Slick to do the changes. Well, it's something that is certainly important, and when we have the resources, we will certainly work on it. At the moment, we don't have anybody working on that.
I'll hold that for you. I've had projects where we run a script, and that's all an evolution is.
But
yeah.
one step might fail. We don't know what happened.
No evolution support today.
So let's get back to the example. So now I created the table in my in-memory database, and now I'll insert some data. So this insert all allows me to just insert a couple of objects at the same time. So let's just get me mask here. Well, for now I just write the ID columns by hand. Slick can also handle auto-increment and primary keys, but for the example I do it by hand. And these are the people somehow involved in Slick. And well, let's pretend we're all in the beginning of our 20s, just for the example.
You have an extra there.
Yes, exactly. Oh, yeah, that's a nice example. If I would do that, if I would have done the same in SQL, it would have told me that there is a comma too much when I executed the query. Now I already saw it in my IDE. Okay, and just for starters, let's just get just the people out we just inserted. I said you have explicit control over when a query is executed. When you write this comprehension, it's not executed yet. What this thing returns is just something representing the query. So when we now go ahead and print it, we will just see an object that represents the query, not the results yet, and there will be no communication with the database yet. So now I print the results, and right here I use a new feature of Scala 2.10, which is string interpolations, which allows me, when I prefix a string with this S, to just reference variables which are defined outside and insert the things here. And this is also typesafe. So I'll just have this template and insert the result here. And then I'll start spt from the command line and let spt run that file. There we see this two-string representation of this query object. If I, however...
If you can't read it, it's a Scala slick lifted wrapping query.
And then some identifier. Yeah, but if I now choose to execute the query...
You could just say results.list right there.
Well, I could, that's true. You can not only have reference to variables, you can write arbitrary Scala expressions between these dollar braces. Then it should actually print out the results, which is a list of our people, which is this. And so let's filter the people for those above 21. So, and actually I get code completion here. Well, no, you can actually complete it. But it's the Eclipse plugin for the Scala pre-release, and sometimes things are not working completely. No, but for example, if you do this here, you get this, and you get the completion. IntelliJ works as well for that, yeah. So let's say above 21.
But not with 210. Yeah.
Does it work properly with 210, IntelliJ? No?
Not today. Not today.
Yeah, there are some
Soon.
quite some additions.
Yeah.
And let's first take the ones above 21, and let's also sort them by name. And, well, before we saw that, well, H2 just gave us the result, the objects back in the same order we put them in. And so only Martin and Stefan are above 21, and Stefan came before Martin, but when we sort by name, now Martin should come before Stefan. Let's see. And there we go.
So is it showing the SQL query generated? I see blank there.
Yeah, it's blank because I didn't write the code yet, but we can, actually I can add that right now, so we can just see right away. Yeah?
The question, so when you do the sorting, is sorting done in Scala? Or do you have some communication with the server so you can do some sorting on the server side?
As long as you didn't write .list, everything you will append to it will happen as SQL on the server side. Just when you say .list, then the transfer to the client side happens, and when you then write sort by, then that will happen on the client side. So you can explicitly say where the transfer happens, and after that you're locally.
What he didn't say is that Slick is a DSL that looks like Scala. As a DSL, it translates to SQL. Actually, you did kind of say that, didn't you? That's
hope
what's
so.
going on. It looks like Scala. It's not Scala. Remember my fake question before about what happens if you put a debug? Right?
Yeah. Of course, when you try to, with an interactive debugger, if you try to debug, for example, the iteration of something that is translated to SQL, you cannot see the iteration in the database in your Java debugger, of course, right?
But you could make it local and then debug that.
You could do that. And actually, it could be pretty easy to just change it to be processed locally and then go back to.
Why do you call it list instead of two lists? So it's like more.
See, that's 2 votes.
Yeah, okay, maybe we should add to list as well. Actually, there is a method. There's a method to which takes a type argument, and then you can choose whatever type you want: set, list, map.
It's inconsistent.
Okay.
We have opinions on these things.
Yeah. Okay, so.
I'm just supposed to hold the microphone, but
Yep,
I'm here, so.
you're commenting. So.
There's beer later, right?
Absolutely. So, you asked for the SQL output, and I'll add that right now, that we will see every time what SQL Slick actually generated, because it's nice for debugging to know what's happening. Yeah. And let me just give this a more speaking name. Well,
Or a descriptive thing.
yeah. People above 21, and that's just our query, not the results yet. And there is this method .select statement, which will give you the select statement. And sorry? Yeah, exactly. That is still. And now we can see the SQL query. So it's, as you can see, the order by part is in there as well, and not locally in Scala. Okay. So now we have the people we need. Now let's look at tasks. Let's go back up and define a class for tasks. And a task belongs to a person. So it has this person ID. And the tasks table maps to a table with the name task in the database, and has a column ID again.
It
Title.
almost seems like that idiom should be have an alias available.
Yeah, you can abstract it easily if you want. Nope, we have a person ID here. And what I'm not going to do now is tell Slick that it's a foreign key. We'll just do it by hand, but you could tell Slick it's a foreign key, and then you get some advantages when you write queries. So you have, I have an example in the slides about that. And the star projection again. Nope, there's not H. Yes, and now we also need to create this table and insert some data.
So you were running the code multiple times, right? And DDL.create is being called, but there is no error?
The thing is, I create an in-memory database at the moment when I start the program. So every time I run it and the database is created, the tables are created and the stuff is inserted, yeah.
However, the bug you mentioned is true in the official Slick example. If you change it as I did, I forked the project and I used a MySQL driver. It fails every time because the table's there. And so I had to write some more code which says, oh, if the table's there, we're going to drop it. It would be good if that was done. So I have a pull request on that.
So let me just create a couple of tasks, and I just call them task 1 to 8 for now, to keep it simple. And, well, the first task, the first task I assign to me, and the second to Stefan, Martin, Eugene, another one to Stefan, Martin, and one for me. And what we do now is look for the tasks of these people. And for this, we go over the tasks. And, well, we yield the task. But we only want those tasks which actually belong to those people. And we can do this by saying where task.id, person ID is in, and now we need the list of IDs of the people, but we need them in the database because we're writing the query. What we can do is we can just reuse the query we wrote above and say, well, we use this and we map it to the ID. And this also shows how Slick is compositional. Where did I mistype something up there? Let's see. Oh, yeah, I need an if here. Okay. So you can easily, just like you write any other code, you can just abstract parts and reuse them and mix and match. And, well, this. Okay, and now I'm going to go over the results of the people, and for each person get the tasks for it. But because I don't want for every person to execute another database query, I'll get the tasks in advance. So first I'll get the people are right here, and I'll also get the tasks right here. Oh wait, let's do it like this. So I have the query separately so we can ask for the SQL for them.
What if you wanted to join?
You can do a join. I'll have examples in the slides in a bit.
It's coming.
Yes. You can do all kinds of joins. Inner joins, outer joins, left, right, full.
It doesn't automatically figure that people 21 query that, it's ideally the best would be that, if you could reuse the same object.
You can do that. And I have a slide about that. It's actually very flexible. You can describe any type of relationships, not only one to n and n to n. You can also go over 5 tables and have some conditions in there. And
that's pretty cool.
Yeah, we'll see that in a bit. And now I'm building the result string. What I want to do is I want to have, for every person, I want to have a line where the name of the person is first, then I have a colon, then I have a comma-separated list of the tasks. So I'll write people above 21 dot map. So I project the people. Well, this is already working on the results I already fetched from the database, and I map the people to. Well, I map them first to their name, and then I concatenate a colon, and then I concatenate. Well, then I need all the tasks, right? And what I'm going to do is their tasks, but I only need the task for that particular person. And then
Triple equals?
nope, not there. Yeah, I'll get back. There are some slight differences between how you write queries, how you write comprehensions in Slick, and how you write comprehensions in Scala collections, which have implementation reasons. And we have some plans to get it closer together. I'll get back to that point.
This is still a Slick DSL, right?
Well, right here we're working on the results. So this is Scala collections now.
Okay.
Exactly. So above here we wrote database queries which were written against the Slick library. Down here we write operations against Scala collections written in the Scala standard library. And well, it looks almost the same. Okay, so I take the tasks, I filter out the ones that belong to the person. I only take their titles, and then I I join them with a comma. Welcome to functional programming. And then now we have mapped the people to this string, and now we'll just join this list of strings with a line break. So in the end, it should give us this, what we're looking for. Yes, I want to get rid of that, and instead I want to put this whole string into a variable and print that here. And down here we can also print both SQL queries. Huh? Okay, so yeah, I just extended the output here. Let's see what we get. A compile error. Okay, because because what I actually accessed here is the list of results which are already retrieved, but what I want here is to plug in a query, not a result. So I want to actually map the query to IDs, which happens in the database, instead of map the persons which are already collected. So that part can happen in the database as well. Okay, and well,
Yay.
No?
No?
Well, they should have more tasks, so let's see.
It's vacation.
I guess. Okay, let me check. So they only had one task each, but they had more assigned. There has to be a bug somewhere.
Impossible.
Let's find it. Yes, because I match the task ID against the person ID, but I should match the task's person ID against the person ID to get this. And this is a very good example where he was exactly right, asking, can't we put this in a central place and reuse it? And yes, we can. I just didn't do it here. But if we put it in a single place, then we will not have this problem again the next time we join.
Build your software out of components.
Exactly. Okay, so now we have the tasks. Yeah, and that was an example of some Slick queries. And now I hope you have a feeling how it works writing Slick queries. Thanks, Mike, for the help. Okay, so let me run you through a couple of features the query or Slick supports as well. You can do sorting I showed you, but you can also do drop and take for pagination. You can do group by and aggregations, length, count, average, stuff like this. You can do something like first, where you get the first element of a list. For example, when you know it only has one because you got it by ID. You can union things, and there are more things. Slick also has null support. Scala has this concept of option, where you can handle something just like null in the database, and you can map this to option as well and handle it in a safe way. You have support for outer joins. If you have nulls, you also may want to outer join. You can do left joins, right joins, full joins. Yeah. You can, well, this slide looks very full, but it's not that complicated. Let's have a look. You can handle arbitrary relationships. Before we had the one-to-n relationship between people and tasks. Now we make it, in this example, an end-to-end relationship. And there we have this object persons and object tasks, which we defined before, these table objects. And now we have another one at the bottom, which is the person's tasks associations to associate the two in the end-to-end relationship. And as an example, I put one foreign key in this thing down there. So this assignee down there is a foreign key that tells me, okay, the field person ID goes to table person and the field ID. And we can then, well, if you look a little above in the center of the slide, you see a query. Ignore the left-hand side, but we can use this foreign key relationship in this query just to have this reference in a single place. And what we do here actually in this query, we give the object tasks an attribute assignees, which returns a query that gets me the assignees. So it goes over this association table, uses a foreign key, and gets me the people connected to it. But you can write any kind of query there. You can become arbitrarily complex, go over several tables, have some conditions in there, things like this, to connect what you really want to each other. So the concept of end-to-n or one-to-n is not hard-coded in Slick. You code it the way you want to, and you have the flexibility to do so. Slick also supports quite a number of operators like in, not in, count. There are numeric operators and string, and you can look it up later. And those are all modeled after their Scala counterparts. So they, well, you use them just like you use Scala. Slick can handle auto-increment values, can have subqueries, you can handle these case conditional statements, prepared statements, you can map custom data types to your rows. You can have for each iteration where you go over a result set one by one if it's large, so you don't need to get everything at once. There are more things. And well, let's have a quick look under the hood. How does Slick actually work? And this is the overview. Your app either talks native SQL to Slick, and then it's sent to the database, and you get the results back, or you use the API, which is modeled after Scala collection and just looks like it. And with this API, we use a technique called lifting, which allows us to obtain trees that describe the queries. They describe, well, there was a filter, and there was a comparison, and things like this. And we have this tree that describes this. And from this tree, we then generate SQL. Or in the future, we could generate queries for NoSQL databases. Another thing that having these trees, another thing what it allows us is to do optimizations there. We do some very simple optimizations which are more a side effect of our implementation right now. For example, for subqueries, we eliminate columns which are not used. But most of the things we do right now, probably the database optimizers would have done anyway. But from the structure, we have the potential, and we also have the plan to add more optimizations there that may not be supported by certain database backends. And well, we have the infrastructure to do it. Now I'll tell you quickly how lifting works, the technique to get the trees from these queries. The first line is the Scala for-comprehension syntax, which the Scala compiler already desugars into this method syntax. So what we need to do to support comprehensions, implement these methods, filter and map, and then we have comprehensions. And the way we implemented them is, of course, we don't execute map in the way that we iterate over something, because that needs to happen in the database. It just returns an object that it represents this operation. And so do the operations, for example, this expression which is passed to filter. It also just returns something that represents it. And well, it also, when you use Slick, it doesn't have the same types like when you use real Scala collections. It has these column of string and types like this. And triple equals, which you use for comparison there, is defined on this column of string, not on the real string. And there's an implementation reason why we have to use triple equals here instead of double equals like you do it in Scala to work with these column types. And this is one of the examples where the syntax of the queries in Slick slightly differ from how you write collection queries. And well, that's the tree, or well, that's not exactly the tree how it looks like in Slick, but roughly to get you the idea, this could be the tree that represents the query. The filter call becomes the filter node, and the map call becomes the projection node. And this expression becomes a subtree there that tells, yeah, it's an equal comparison between this field and this constant value. And from this, we can then go ahead and generate the select clause and the where clause and the, well, parameter, the condition in the where clause. But we could also generate something else. And what we have been working on the last year actually is, one of the things is generalizing this tree to let it have it be less tied to relational and make it general to be able to, in the long run, generate NoSQL queries and other backends web services. I can tell you more if you have questions after the talk. So what's coming up? What I showed you until now, this API that was modeled after Scala collections, is something we call lifted embedding now, because we're working on an alternative front end which uses the new macro feature of Scala 2.10 to get the API closer to real Scala collections, get rid of the triple equals and some more things where the differences are. This is one of the reasons. And this is why we have the lifted embedding, which is stable and usable right now, and the direct embedding, which is already in the pre-release in a prototypical state, and you can try it out, but it's not completely there yet. And another angle on the direct embedding is Scala macros are snippets of code which you can put in a library, which are called by the compiler. So we can execute code at compile time. So we could also do optimizations within the trees at compile time. We could even generate SQL at compile time already, and not have this overhead at runtime. So that's future. We are not working on these optimizations yet, but we're putting the infrastructure in place to do it. Sorry? The question is, what do I mean by generate SQL at compile time? When you write a comprehension that represents a database query, and you have access to the tree representing this comprehension at compile time, you can already translate this tree to SQL at compile time. Yeah, exactly. You could already translate the Scala code you wrote to write a database query into SQL during compilation of the Scala program. However, this will only work up to a certain extent because of separate compilation and because of composition. And we still have to investigate what we can do there. But that's something we're preparing Slick for. Right now, we only integrate this front end. We don't leverage everything we could do with it yet. And another thing we may do then is have more compile time checks, possibly backend dependent compile time checks. If a NoSQL database doesn't support joins, we could at compile time say, well, you can't do this when you're using this backend. Another thing that is coming until next summer is the concept of type providers. Right now, macros can transform code, but they cannot generate types, Scala types. But we're working on that. Well, that's more a Scala feature than a Slick feature, but Slick will use it to generate types, well, look at the database, connect to the database at compile time, look at the schema, generate types at compile time. Microsoft does something like this under the term of type providers, and we'll do it slightly differently, but it's a similar concept. And another thing I already mentioned is that we're opening Slick up for other backends. So you will be able to hook in where we have the query trees and translate them to other languages. So more far in the future is the idea to allow using different data sources within one query. For example, do a join over something from an Oracle database with something from a MongoDB. And this, well, the tricky part will be we have to decide what part to execute where. Something in the Oracle database, something in the NoSQL database, and something locally. And we have to investigate how much can be done automatically, how much control we need to give to the user. But that's something we have on the long-term agenda. Things like this, how do you control transactions? It will be interesting to explore, absolutely. Yeah, maybe. Another thing you cannot do with Slick right now, but also not with the other solutions out there, is have a result, which is a list or a set or something, that consists of tuples or case classes or nested tuples or nested tuple case classes, which in turn contain a container again, like a list or a set or something. You cannot directly express this with SQL because with SQL you always get a flat, like a list of or a set of something flat. That's something I explored in Scala integrated query, and I demoed a prototype that actually does this in 2011 at Scala Days. But it was a research prototype. But in the long run, we'll integrate this into Slick, and it's based on a compilation. Well, what I used is a compilation technique called Ferry, developed at University of Tübingen in Germany. And yeah, we are exploring this and other methods to do this, to make Slick more powerful in this regard. Something that maybe comes next year if we can find a good way to do it. It's more a Scala feature. It's an extension of the Scala language, a purely syntactical one, not something that gives you more power, just makes it nicer. Right now, for-comprehensions allow you to do an iteration or a map, and it does allow you to do a Cartesian product over several collections. It does allow you to filter, and it does allow you to do a projection in the yield part. There is no syntax for doing a sorting or for grouping like SQL has it. You can do this by putting parentheses around it and just call the method. But it's not syntactically integrated, and we're exploring how to integrate that. We are working on a Scala improvement proposal at the moment to see how we can do this. There are several ideas we have found. But this would be just a change of Scala again, which Slick would use to make its syntax a little nicer. Sorry? We could support comprehensions, but within the comprehension, there's no syntax for stating that you want to sort something or that you want to group something, for example. This used to be the same in Haskell, and at some point they extended the comprehension syntax, and they published a paper under the name Comprehensive Comprehensions, where they integrated more syntactical constructs into the comprehensions. And that's something we're exploring as well. So to sum up, I showed you how Slick makes database access easy when you know Scala, because it's just how you access collections, and it simplifies the session handling. I showed you how Slick queries are concise. It's Scala code. Scala code is concise. And also getting the results is pretty easy. I explained how Slick is scalable because it's stateless and because you have control over what is happening. I showed you how it's safe because of type safety and the protection from injections that comes with it. And I showed you how Slick is composable, well, because it's source code, Scala code. You can just compose it and abstract it and use it like you want to. And I gave you a little outlook how we are planning to make the syntax easier by getting rid of the differences between collections and Slick query, so you don't have to think that much about, okay, now I'm writing a query against the database when you do it, but you can just write it. And I showed you how we are opening up Slick for extensibility to other backends, how we're planning to make Slick faster in the long run with automatic optimizations of your queries before they are compiled, and how we are thinking about making Slick more powerful by providing nested results types. These are the people. Stefan, Zeiger, and I are the core team. Oh yeah, one thing I didn't tell yet. Some of you may know ScalaQuery, which I mentioned before. And ScalaQuery was a library Stefan was working on until he joined Typesafe 1 year ago. And at that time, I was working on Scala integrated query. And then we joined forces and started working on Slick together based on his stable implementation, which was ScalaQuery back then, and now rebranded to Slick and extended after that. And, well, I guess you all know Martin and Eugene. They are working heavily on reflection and macros, which are now essential features for Slick to work. And that's what I wanted to tell you about. Thank you for your attention. Are there any questions? Yes, please.
Yes, so you mentioned that this was inspired a lot by Link or Plink on the .NET side. Can you contrast, just summarize the difference besides the fact this is Scala integrated with Scala? Contrast.
Well, Link, one thing Link did is it extended C# and Visual Basic for syntax that allowed comprehensions, basically. They didn't have that before. We already had that in Scala before. And so there are several libraries who model or who work with these comprehensions already. And that's, I wouldn't say that's inspired by Link yet, because comprehensions are a functional programming concept, and, well, Link took it from functional programming. What I consider inspired by Link is the idea of having these expression trees and compiling them to different backends. And, well, we're still working on opening this up. And this is from the rough concept similar to how it would work in Link. And the question is if comprehensions came from Haskell. Or, the concept of...
I don't think Link invented that.
So that was more a comment, right? And the comment was, I'm just repeating it so people hear it, and so it's also on the video. So the comment was, you think it's more important to soon support NoSQL databases rather than some obscure SQL dialects, and I agree. And
What I mean is focus on a few like MySQL, Oracle.
well, you've seen the list of drivers we have, and they are there. You can use them. But we're definitely working on NoSQL database, and we're in particular working on MongoDB. So there will be a MongoDB driver next summer. Okay, so your comment is if we want Scala or Slick to be associated with high availability, we should rather focus on Cassandra and on. Any more questions? Okay, then thank you.